Okay, so good morning to everyone. So
Morning.
yesterday, in yesterday's class, we have discussed about the quality of service, and about the quality of service, we have discussed the flow characteristics, that there are the four flow characteristics present, that are the reliability, jitter, then delay, and at last the bandwidth. These four characteristics are present, and according to these four characteristics, we have said that why these four characteristics are needed. And then today we will discuss about the techniques, some techniques that is used to improve the quality of service. So to improve the quality of service, some technique is used. Today we will discuss about that which are the techniques that is used to improve the quality of service. Now, the techniques to improve quality of service, it is already broadly known as the scheduling techniques. Now, this scheduling concept is same as like that of in the operating system which you have done, like that, the scheduling techniques. So some scheduling techniques is used to improve the quality of service. Now, the first technique among them, the first technique that is used is the Fifo queuing. The first technique that is used is the Fifo queuing. Now, Fifo, the name suggests that Fifo means what? Fast in, fast out. That is the concept for the Fifo, fast in, fast out concept. Now, the name suggests that Fifo queuing. Now, Fifo means fast in, fast out. So, in this, the packets waits in a buffer. In this, the packet came. So, the packet which are coming into the network. Now, the packet waited in a buffer or a queue. The packet which came are waited in a buffer or a queue until the node is ready to process them, so that the packet which is coming, it have to wait until what time? Until the node is ready to process that packet. Until the node is ready to process that packet, until that it has to wait. Now, where it has to wait? It has to wait in the buffer or a queue. So the packet, in this, the packet waits in a buffer or a queue until the node is ready to process them. Now the packet which came fast is processed fast. So the packet which came fast, it is doing in the FIFO order. So that's why those packets which came fast will be the process fast. That is known as the FIFO queuing. Now, if you see the diagram, it will be clear to you. So if you see this diagram, you see first the packet is arrived. The packet will arrive. Now there will be a queue present. Now in this queue, what this queue consists? This queue consists of packets. So let's say what? 1, 2, 3, 4, 5, 6, 7. Now this queue capacity is 7. We taken that this queue capacity is 7. That means this queue at a time can contain 7 packets. This queue at a time contain the 7 packets. Now when the packet came, at first the packet will be inserted, or packet will be added into the queue. But before that, what we have to check? That the queue is full or not. The packet is arrived, but the capacity of the queue is 7. Let's say we have taken that its capacity is 7. So that means the packet is arrived, but first we have to check that the packet can be added into the queue or not. So that's why you see the condition is used, that the packet arrived and checked that the queue is full or not. The queue in which the packet is stored, its capacity is 7, it is full or not. So if it is full, then we directly discard the packet. The packet which came, we directly discard it because the capacity is 7. So example, let's say example, the 8th packet came. So 8 packet cannot be stored into the queue because the queue's capacity is 7. So then what will be we will do? It will be the packet will be discarded. But if the queue is not full, if the queue is not full, then the packet will be added into the queue one by one. So if the queue is not full, then the packet one by one into the queue. And after that, what it will happen? Processor will do what? It will the packet that came fast will be called by the processor. That means the first packet will be processed by the processor at first. And after processing, the packet will departure. So this is the concept of the FIFO queuing for two in that our techniques to improve the quality of service. So this is a technique to improve the quality of service. That means the packet is arrived. After arriving of the packet, it will be seen that it can be stored into the queue or not. If the queue is full, then we cannot store the packet into the queue. So that means the packet will be discarded. But else, if the packet can be, we can store the packet into the queue. That means the queue is not full. Then the packet is added into the queue, and after that the processor will pick what? The packet which is stored fast will be called by the processor, and the packet will be processed and it will departure. The packet will be departured. So this is the concept of the FIFO queuing. Clear?
Yes, sir.
It is clear to everyone? Okay. So this is the concept of the FIFO queuing. So next, there is another, that is the priority queuing. This is the next, that is priority queuing. Now, priority queuing is what? It's based on priority. The priority queuing is based on some priority. Here, priority class is assigned to the packets, and each priority class has its own queue. So the processor will pick from the queue which has the highest priority. So the diagram is almost like a same. If we say that the packet will be first arrived, let's say the packet will be first arrived. Now, after arrival of the packet, there is a portion that is the classifier. You see, there is a portion that is classifier. So that means the packet which is arrived, classifier will do what? It classifies the packet. The classifier will do what? It classifies the packet which are coming according to the highest priority or low priority. So there may be several queues should be present. Some queues should be present and the priority is given. In this example, you see, I have taken two queues. I have taken this queue and this queue, two queue. One queue has the highest priority and another one is the low priority. So that means the packet is arrived first, and after arrival of the packet, the classifier do what? It classifies the packet according to the priority, that it is what is it is highest priority or it is on the lowest priority. So if it is the packet that is arrived is the highest priority, then the packet should be added to the high priority queue. That means if it is packet is high priority, then it should be added into the high priority queue. But if it is of the low priority, then the packet should be added into the low priority queue. So classifier basically does it, that classifies according to high priority and low priority. If high priority, then the packet should be added to the high priority queue. But if it is low priority, then the packet should be added to the low priority queue. Now, same thing, that the packet first will be checked that if the queue is full or not. If the queue is full, then the packet should not be added, it will be discarded. And if it is not full, then the packet will be stored into the high priority queue in this example. And if classifier Okay, so some problems happened due to which the voice is not coming. So now let's the discussion that we will proceed that then the packet is classified, and according to it, that if it is high priority, then it will be added into the high priority queue, and if it is of the low priority, then it will be added to the low priority queue. Now the first, the packet is arrived, that is checked. If it is high priority, then it will be in this order. It will be checked that it is full, the high priority queue is full or not. If the high priority queue is full, then the packet, we will not able to add it, so it will be discarded. And if we are able to, that means if it is not full, then it will be added to the high priority queue. Same as that, if classifier classifies that it is of the low priority packet, then it should be this low priority packet should be added into the low priority queue, and then it will be checked that it is full or not. First it will check it is full or not. If it is full, same as that, we cannot able to add it. But if it is not full, then the packet we add it to the into the low priority queue. So one by one the packet should be added like that. So this is the thing. Now the packets are added into the front end of the queue, and now the packet which are present in the high priority queue, processor will pick that particular packet fast and process it. Now happens what, the packets that both in the both section the packets are added. In the high priority queue the packets are added also, and in the low priority queue the packets are also added, according to which the classifier classifies. But basically the processor do what? Processor basically pick the particular packet high priority queue, because processor basically do what, that which packets are present in the high priority queue, processor will pick that particular packet first. So the packets that is present in the high priority queue will be picked first. Now this is okay, but this makes the problem happens. Now what problems happens? If you remember, there is the concept in the operating system, that is the starvation concept. That is the starvation. Now, like from low priority queue, no packets are choosing. No packets are chosen. That may happen that the processor always speaking from the high priority queue packets, and no packet is chosen from the low priority queue. Then what happens? If the low priority queue never get a chance to be processed, that means the packet that is present in the low priority queue never get a chance to be processed, then we called it as a starvation. Because processor has the tendency to do what? Processor has the tendency to pick up the packet from the high priority queue. Pick up the packet from the high priority queue. So processor will pick the packet fast and process it, and no packet will be chosen. So scenario happens that the no packet is chosen from the low priority queue. Then what? So starvation problems. This is the disadvantage of priority queuing, that the starvation problem may happens. So for overcoming this, the next technique, the weighted fair queuing technique is used. The weighted fair queuing technique is used to solve this starvation problem. To solve this starvation problem, we use that. The next, to solve this problem, we use weighted fair queuing. Now, in this, the queues are weighted. In this, the queues, all the queues that is present, a weight is given for each of the queue. A weight is given for each of the queue, and based on the priority of the queue. So based on the priority, the weight is given. Now what? Here, some changes, you see, some changes happens. What changes happens? Same as that, here also the packet is arrived, and after arrival, there is the classifier present which classifies the packet according to the priority. This classifies the packet. Now here you see each queue has some weight given. Now this queue, the weight is given as 3. For this queue, the weight is given as 2. And for this queue, the weight is given as 1. So each and every queue, a weight given. In every queue, a weight is given. Now, in this queue, let's say we have added 4 packets. Let's say in this queue, 4 packets is present. 1, 2, 3, 4. Same as that also, for the second queue also, there is 4 packets present. And in the third queue also, there are 4 packets present. Now, this all are connected with a switch. This all queues are connected with a switch. Now, this switch is what? This switch is a rotating type kind of switch. This switch is a rotating kind of switch. Now, depending on the weight of the queue, depending on the weight of the queue, the particular number of packets is chosen. This switch will do what? This is the rotating. So this is what? This is weight is 3. So that means this is the highest priority queue. Is 3. So that is the highest priority queue. So that means now the according to what I said, that this is the rotating switch. So this rotating switch will first go for the highest priority queue. Now rotating type switch will do what? Depending on the weight of the queue, it will select the particular number of packets. Now the weight is what? The weight is 3. The weight of this queue is 3. So the rotating switch will go to the highest priority. So this is the maximum weight of the queue, because it is 3, another is 2, another is 1. So it will go towards it. It will go towards it, and because its weight is maximum, so the rotating switch will go towards the first queue. Now, what I said, that the rotating, depending on the weight of the queue, it will select that the particular number of packets. So that means its weight is 3. This weight is 3. So that means the rotating switch will do what? It will pick 3 packets, because according to the weight, the packets will be chosen. So 3 packets from the queue are chosen, and it will go to the processor for processing purpose. So processor will process them, and that packets are departed. So that means here you see 1, 2, 3, 4. So among them, 3 packets are chosen. So how 3 packets are chosen? Because its weight is 3, and according to the weight, the packets are chosen. So if it is 2, then the 2 packets will be chosen. If it is 1, then the 1 packets will be chosen. But here the weight is 3, so the 3 packets is chosen. And here you see only 1 packets left. You see only 1 packet, this packet is left. Others are chosen. After doing this, the switch is what? This is rotating. So after doing this, it will came to the second queue. It will came to for the second queue. Now in for second queue, here in the second queue, you see the weight is 2. So that means according to the weight, the packet will be chosen. So from here, the 2 packets will be chosen from the queue, and it will be go to the processor for processing, and the packet will be departed. After that completing, it will, this switch will go to third queue. So the switch will go to the third queue. Now in this third queue, the weight is given as 1. You see the weight is given as 1. So from here, the 1 packet will be chosen, and it will be processed and depart, and after that it will be departed. So that means you see now from the packets are chosen from all of the queue. But if you see in the priority queuing example, only from the highest priority queue the packets is choosing. Only that. In the low priority queue, the packets is not chosen. So it becomes the starvation problem. But here you see, according to the weight, from all the queues, the packets is chosen. So it is going, there is no problem like starvation happens. If you see that, it is mainly what? It is the round robin scheduling. This is the concept of the round robin scheduling concept. This is basically the round robin scheduling concept. So there is no starvation problem happens. Now we see in the lowest priority queue, packets are also processed. But if we see in the priority queuing, here from the low priority queues, packets are not processed, because processor has a tendency in that the packets are chosen from the highest priority queue. But if in this example, if you see for weighted fair queuing, this problem, we solve this problem. Now how we solve this problem? We solve this problem using here that the packets are chosen based on the weight of the queue, and this switch is a rotating switch, so it will go fast to the queue that has the highest priority, and it will check what is the weight of that queue. So according to the weight of the queue, the packets is chosen. So here it say that the first queue, that its weight is 3, so that means it has the highest priority. So the switch goes to here, and from here it is seen that the weight is 3, so 3 packets is chosen. Then after completing, the processor process it, and the packet is departed. Then the switch roll over and it comes to the second queue. Then in second queue, it says that the weight is 2. So, oh, this weight is 2. That means what? 2 packets will be chosen from that queue. So 2 packets, the switch chooses 2 packets and process them, pass it to the processor. Processor does what? Process it, and that departed from there. Then again the switch rolled over and came to the third queue. In third queue, it says that the weight is 1. Oh, the weight is 1. So that means from here only 1 packet should be chosen. So it chosen 1 packet, and from there the packet is chosen, and it starts pass to the processor, and processor process it, and it is departed. Now you see, this is basically what? This is the round robin scheduling example. In the round robin, also, if you compare within the operating system, there is a time period, the time slice given. According to this time slice, this is given, the processor is given to this process, and after the time period, the next process will be executed like this. So this is the concept of the weight fair queuing concept. So these are the 3 techniques. These are the 3 techniques, that is Fifo queuing, priority queuing, and weighted fair queuing. This is the 3 techniques through which we can ensure, or we can say, to improve the quality of service. We can improve the quality of service. Okay, क्लियर है इस तक? सबको समझ में आया अब तक?
Yes, sir.
Okay. So this is about the 3 techniques to improve the quality of service. Now we have already seen the quality of service. Quality of service we have already seen. Now today we will move another topic. This is about, now up till now we have seen about how the congestion is occurred, how congestion is controlled, how quality of service, and how we can improve the quality of service. We have already seen that. Now we will see that topic, that is the quality of service traffic shaping. Now traffic means what? Already I have said that traffic means in networking is flowing of packet or data. That is basically the traffic. This is basically the traffic in a network, that is flow of data or flow of packet. This is basically the traffic. Now quality of service traffic shaping means it is a mechanism to control the amount. It is the mechanism to control the amount and the rate of the traffic sent to the network. That means it is used to control the rate of the traffic, means rate of the packet. Basically traffic means what? flow of packet or flow of data. So that means mechanism to control the amount of packet, mechanism to control the amount of the flow of packet or the flow of data that is sent to the network. So to control that, we use the quality of service traffic shaping. Now there are two ways we can do that. One is it is known, one is the leaky bucket, one is the leaky bucket algorithm, and another is the token bucket algorithm. So through this, we can solve the or control the amount of the traffic, to rate of the traffic sent to the network. Now for the leaky bucket. So first today we will discuss the first type, that is the leaky bucket. Now this algorithm shapes the Busty traffic into the fixed rate traffic by averaging the data rate. Now Busty traffic means what? Busty traffic means, let's say if we take like this is the graph. So let's say from 0 to 2, from 0 to 2, the data came at 12 Mbps speed. The data came at 12 Mbps speed. And after that, there no data came. Let's say from 7 to 10, here the data came at 2 Mbps speed. The data came at 2 Mbps speed. This is what called the Busty traffic. Busty means sudden changes of data, sudden changes of data. Now here you see from 0 to 2 seconds, the data came at a 12 Mbps speed. The data came at a 12 Mbps speed. But after that, there is nothing. And let's say after 7 seconds to 10 seconds, the data came at 12 Mbps speed. 2 Mbps speed. So that time it is 12, and after that there is no data. And after that, sometime it is 2 Mbps data. So that means sudden changes, you see, sudden changes of data. This is called the Busty traffic. This is what called the Busty traffic. So this leaky bucket algorithm will do what? It will shapes or it will convert this Busty traffic into the fixed rate traffic. That means fixed rate traffic means what? Like from 0 to 10, let's say from 0 to 10, same amount of data came at the same amount of data rate. Let's say 3 Mbps speed. Let's say 3 Mbps speed. So that means from 0 to 2 seconds, the data came at 3 Mbps speed. That is the fixed rate. The fixed rate data is coming from 0 to 2 seconds. Not like that, from 0 to 2, it is 12. Then after that, there is nothing. And again, from 7 to 10 seconds, the data came at 2 Mbps speed. This sudden changes, this occurring as a sudden changes. But in the fixed rate is what? The same rate, the data came at the same rate. So this is what this is called as the Busty traffic, and this is known as the fixed rate traffic. So leaky bucket will do what? Leaky bucket algorithm shapes this Busty traffic into the fixed rate traffic by averaging the data rate. Now, why this name is given as a leaky bucket? It is a very thing that why this name is given, that the name is leaky bucket. Now, this concept came first with here, you see, this concept came from a basic real thing. From real thing, this concept came. Now, the real thing from which the concept came is like that. There is a tap, there is a tap. Now, from this tap, the water is dropping. The water is dropping from this tap. And in this below of the tap, there is a bucket placed here. There is a bucket placed here. Now, in this bucket, in the bottom, there is a hole. There is a hole present in the bottom. So now the water is dropping in the bucket, and in this bucket, in the below, there is a hole. Now, here we say that it is the burst flow of water. Now we open the tap mouth and the water which is dropping, it is the burst flow of water. It is the burst flow of water which is coming from the tap, because the water is dropping continuously. The tap is open and the water is dropping continuously. Now to control this, suppose we have a bucket in the below and that bucket has a hole in the bottom. That's why it is named as leaky bucket, because the bucket has a leak. So that's why it is named as given as a leaky bucket, because it is leaking. Now continuously the water is pouring into the bucket because the tap is open. So the water will be pouring into this bucket continuously. And any time arises that this bucket become full and the water splashes out. The water splashes out. In same time also, there is a leak present. There is a leak present. Now, the water that splashes out is the discarding drops of water. The water that is splashes out is known as the discarded drops of water. And now this is what? This is the discarded drops of water, because the bucket is full and the water is splashing out. Now this is called as the discarded drops of water. And in same time from the below of the bucket or the bottom of the bucket, there is a hole present. And from this hole, one drop, one drop, one drop, one drop, like that, the water is going out. Now, if you see, this is what? This is the burst flow of water. And here you see every time one drop, one drop, one drop, one drop, like that, the water is going out. So that is the fixed flow of water going out. So burst flow of water is pouring into the bucket and fixed flow of water is going out from the bucket through the hole. And if the bucket is full, the water splashes out. We called it as the discarded drops of water. From this concept, if it is a real life problem, now they think what? If this concept we can take into the network, then in network also, if we say that the data is sending, like that, the packet is sending or the data is sending. If in place of this bucket, if we use the queue, then what? The packet will be, and this burst flow of water drops, if we convert it into our packets, then that means what? Burst flow of packets came. But if the queue is full, then it, like that in real life problem, the drops of the water splashes out. So if the queue is full, then the packet should not be added to the queue. And from this queue, the processor will what? The processor will pick the packet at a fixed rate. So this concept, we say this concept, they do what? This concept, same concept is applicable in the network also with the help of queue. So if we say the packet is arrived, and if it is full, the packet is arrived, and if it is full, then what happens? If it is full, then the packet is discarded. Same as that concept of the bucket, that if the bucket is full, then discarded drop of water. That is the concept, that if it is full, then the packet will be discarded. Otherwise, the water is poured into the bucket. Same as that, the packet will be poured into the queue. And after that, the leaky bucket algorithm works here. And leaky bucket algorithm will do what? It fetch the packets from the queue at the constant rate. it will fetch the packet from the queue at a constant rate, and processor do what? Processor process it, and it will be departured. Okay, so this is the concept. So today the time is so much less, I am not able to discuss it fully, but in the next class we will again start from here. So till now the concept is clear to everyone. The concept is clear.
Yes, sir.
Okay, so I will again explain it from here because today I am not able to discuss it fully. But the main concept is, if you think in the mind that the tap, and in the tap the water is going out from the tap. Now the water is going out with a busty water drops. That means the flow of the drops are not constant. And after that it will be poured into the bucket, and below bucket the water is going out through a hole, but the water is going out